Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear student, Assalamu alaikum. Dear student, Assalamu alaikum. Today, our lecture. Today's our lecture is. I'm going to start. Class 9th subject physics, chapter number 6, work and energy. Topic of today's lecture is 6.7 continuation. We are using the same topic. Pages covered today's lecture 132, 33, 134 and 135. I repeat, class 9th subject physics, chapter number 6, work and energy. We are doing topic of today's lecture is 6.7 continuation 132, 133, 134 and 135. Video. Next. Okay, the work and energy unit number 6, work and energy we are doing. Next, today's topic is wind energy, which is a continuation of, as we discussed earlier, solar cells, energy from water, energy from sun, solar house heating system, nuclear fuels, renewable energy sources and energy sources. We have already done this. Now this is the same topic, 6.7. Continuation today 130. If you open 132 page of 9th class textbook, the topic is wind energy, which is a continuation of 6.7 topic. Wind has been used as a source of energy for centuries. It has powered sailing ships across the ocean. It has been used by windmills to grind grain and pump water. More recently, wind power is used to turn wind turbines. When many wind machines are grouped together on a wind farm, they can generate enough power to operate a power plant. In the United States, some wind farms generate more than 1,300 megawatt of electricity a day. In Europe, many wind farms routinely generate hundreds megawatt or more electricity a day. So students, wind is the wind energy. We use this wind. These are called the wind turbines. So when they are installed where the pressure of the wind is high, so near the oceans we place them. So these wind turbines used to generate the electricity which is powered, which can power the sailing boat in the oceans. So in the United States, they are providing 1,300 megawatt of electricity a day. So these can also be used windmills to grind grains or turns wind turbines. These wind energies is also used to provide the to turn the wind turbines as well. So in in the United States, they are generating 1,300 megawatt of electricity a day by using these wind turbines. So in Europe, wind farms routinely generate 100 megawatts or more electricity a day. So in Europe and America, they are using these wind turbines to generate electricity 1,300 megawatts in USA on daily basis, and in Europe they are using these wind turbines to generate 100 megawatts of electricity a day. With this electricity is used to in the wind farms. So wind energy is used to turn the turbines to power up the sailing ships. So this is the use of the wind energy. Now I am talking about geothermal energy. You should be very clear what is geo mean, earth, thermal mean heat. So heat present in the earth. There is a there's a hot molten form exists under the earth, which is called the magma. So by using this magma, we can generate the water. We can turn the water into the steam. So we use this steam uh, to uh, to get a hot waters in our houses, industries, or factories. So I explain you now. In some parts of the day, world, the earth provides us hot water from geyser and hot springs. There are hot molten part deep in the earth called magma. This is called magma. This is a hot molten part is available deep in the earth called magma. Water reaching close to the magma changes to the steam. Whatever the water goes near to the magma, because its temperature is too high, whenever the water goes near to the magma, it turns the water into the stream. This energy is called the geothermal energy, because we are using this energy from the earth. That's why it is called geothermal energy, because this is present under deep in the earth. That's why it is called the geothermal. Geo mean earth, or thermal mean heat, or earth providing heat energy. There's a in the deep in the earth, there's a magma present. Molten form exists, which is called the magma. Whenever the water goes near the magma, it turns into the steam. This, you can see, this is the steam. We use these steams to um, geothermal well can be built by drilling deep near hot rocks at places where magma is not so deep. Water is then pushed down into the well. The rocks quickly heat the water and change into the steam. It expands and moves up to the surface. The steam can be piped directly into the houses and offices for heating purposes, or it can be used to generate electricity. This, whenever the water goes near the magma, magma is present deep in the earth. For some area, this magma is not too deep. So whenever the water it goes past through the magma, it turns the water into the steam. This steam is used uh, through the pipes. We use this steam to turn our houses and industries hot, make our water hot. So to provide the heating purposes, this heat is used in our houses and industry for providing heat. So this is the use of the geothermal energy. Next form is energy from biomass. Biomass mean the material which is garbage. Biomass is a plant or animal waste that can be burnt as fuel. We, whatever the waste produced from plants or animal waste or plant is used to generate the, whenever it is burnt, it provides the heats. Other forms of biomass are garbage, from wastes, sugar cane, and other plants. These wastes are used to run power plants. Many industries that use forest products get half of their electricity or burning bark and other wood waste. Biomass can serve as another energy source, but problems are there in the use. So biomass, the energy obtained from garbage, the energy obtained from waste of the plants and animals, it can, whenever it is burnt as a fuel, it provides us the energy, and this energy is used to provide the electricity, or our many power plants works on this principle. But the only problem with this biomass, whenever it is burned in the air, what happens, it gives off the methane gas, CH4. Methane gas is CH4 gas, and it produces a carbon monoxide gas. So that's why it is a little bit harm uh, using this energy from the biomass. Otherwise, it can provide us it can run our power plant, it can generate the electricity as well. So whenever the word biomass comes, it's mean the energy produced from the dead animals, or the energy produced from the waste of the animals, plants waste, or it can also be used sugarcane other plants of farm waste, you can use this to burn this and get the heat from, get the energy from it. This energy can be used to run our power plants, or it can also generate the electricity for us. But the only problem with this energy is whenever it is burned in the presence of air, it generates the methane gas or carbon monoxide gas. Look, when animals dumps dead plants and the animals decompose, they give off a mixture of methane and carbon dioxide, electricity or generated by the burning methane. So we can use the electricity also by using the methane gas. But the only problem is when the toxic gases are produced. So this is the energy from biomass. Whenever the biomass words come, it's mean energy produced from plants, animal waste, or sugarcane, farm waste. These are the sources of generating the energy from biomass. Next is mass energy equation. This equation E is equal to mc square. It is very important equation in the nuclear plants, nuclear power plants. Whenever the nuclear energy is obtained, E is equal to mc square, where E is energy, m is the mass, and c is the speed of light. And the speed of light is 3 into 10 to the power 8 meter per second square. Einstein predicted the interconversion of matter and energy. According to him, a loss in the mass of body provides a lot of energy. This happens in nuclear reaction. The relation between mass m, energy E, given by the Einstein mass energy equation. This is called E is equal to mc square, is called Einstein mass energy equation because it is developed by Einstein. That's why it is on his name. E is equal to mc square, where E is the energy, m is the mass, and c is the speed of light. And you know the speed of light is noted with small c, and 3 into 10 is why its value speed of light in air is 3 into 10 to the power 8 meter per second. The above equation shows that a tremendous amount of energy can be obtained from small quantity of matter. Matter, anything which occupies space and have mass, is called matter. It means a small, by using a small amount of matter, we can generate a tremendous or a great amount of energy. So that matter is highly concentrated from the energy. The process of getting energy from our nuclear power plant is based on the above equation. So getting energy from the nuclear power plant is based on this equation. E is equal to mc square. E is equal to mc square is very important equation of Einstein, which is called the mass energy equation. And this is the energy obtained from nuclear power plant is based on this equation. E is equal to mc square. The process is taking place on the sun as a stars for the last million of years, because sun is the major source of heat and light. Sun is the major source of heat and light. So sun and stars from the million years of years, and there is a process is taking nuclear nuclear thing is happening on sun and stars is the last billion of years. So only a very small fraction of the sun's energy reaches the earth. This is very small fraction of sun's energy is responsible for life on the earth. So so student, the only important thing is E is equal to mc square, which is called the Einstein's mass energy equation. This is very important equation. E is equal to mc square. Only a small amount, with the help of small matter, we can generate a tremendous amount of energy. So this energy, in this E is equal to mc square, m is the matter, m is a small amount of matter, and c is the speed of light. And speed of light is 3 into 10 to the power 8 meter per second. E is equal to mc square. C is the speed of light, which is 3 into 10 to the power 8 meter per second. M is the matter. So energy can be, matter can be changed into energy. Whenever the things are burned, they so mass is lost. So it converted into that tremendous amount of energy. So E is equal to mc square is the main equation. Now we talk about electricity from fossil fuel. Fossil fuel, whenever the word fossil fuels come, you should, one thing only click in your mind, that it gas, oil, gas, and these are the responsible for, this is called the fossil fuel. Fossil fuel, we are using electricity in our houses, offices, schools, business, sanctuaries, factories, and farms. We have different ways of generating electricity. Most of the electricity obtained using fossil fuels. Whenever the word comes, fossil fuels means oil, gas, and coal. Fossil fuels are burnt in thermal power plants to produce electricity. Various energy conversion processes involved in producing electricity from coal are described in, this is the energy produced from the coals. Chemical energy stored in the fossil fuels. Fossil fuel mean oil, gas, and coal. Chemical energy stored in the fossil fuels like oil, gas, and coal. Whenever the coal is burned, heat energy is used to produce high pressure steam in the boiler, and then this potential energy of the steam is used to turn the turbines. Then mechanical energy from turbine is used to run an electric generator, and electricity output from electric generator. So whenever the coal is burned, this is called the burning process. The energy stored in potential energy into kinetic energy, and this kinetic energy transfer mechanical energy, and this mechanical energy into electrical energy. This is the block diagram how whenever the fossil fuels are burned. Fossil fuels mean oil, gas, and coal. So this is the various energy conversion processes involved in producing electricity. From this is the electricity produced, but how this electricity is produced whenever the coal is burned. Various energy conversion processes involved in producing electricity from coals are described in block diagram. First of all, chemical energy stored in fossil fuels. The chemical energy stored in the fossil fuel, this is when it is burnt. This is called the burning process. The heat energy is used to produce high pressure steams in a boiler. So it converts the high pressure, it will generate the high pressure steam. These high pressure steams, where potential energy is converting into the kinetic energy. The potential energy stored in the steam is converting into the kinetic energy. And this potential energy of the steam is used to turn the turbines. So our turbines, by using this steam, we run the turbines, and with the help of the turbines, we can generate the electric generator, and electric generator generate the electricity. Electricity output from an electric generator. So as a result, whenever the electric generators turbine is used to run an electric generator, and electric generator generates the electricity. Here coal is burned, then energy stored in coal, it converts in the steam, and steam drives the turbines, and turbines drives the electric generator, and with the help of an electric generator generate the electricity for us. So this is the whole process how we obtain the electricity from fossil fuel. Fossil fuel mean oil, gas, and coal. Next, 134 page, energy and environment. So I read it first and explain you. Environmental problems such as pollution that consist of noise. So there are different types of pollutions. Noise pollution, the noise generated from the horn, uh, and if someone is knocking at the door, slamming the door, this is called the noise pollution. Air pollution, the harmful things present in the air, like different pollutants present in the air, this is called air pollutant. Like the smoke released from the cars that directly goes, or industries whenever excrete the harmful material, they directly goes into the air. This is called air pollution, because these things are dangerous for our health. So this is called air pollution. And the next is water pollution, may arise by using different sources of energy such as fossil fuels. Fossil, whenever the coal, oil, and gases are burnt, this is called fossil fuel. and they can the water pollution may arise by using different sources of energy such as fossil fuels and nuclear energy. Whenever we use nuclear energy and fossil fuels, whenever we burn the coal, oil and gases, it it uh, it it creates the water pollution. So because we industries are directly discharging their waste into the water, so it will create the water pollution. So so pollution has different kinds. Noise pollution, thus if someone slams the door, this is, or if someone horns, this is called the noise pollution. And air pollution, the industry waste or the harmful smoke coming out of the cars, buses, trucks. This is going directly into the air. It's called air pollution, and the industry waste their harmful material directly into the water. This will create the water pollution. So fossils, whenever the fossil fuels and nuclear power plants work, so they create the water pollution, or they create the air pollution as well. These are the they generate the they generate the water pollution, air pollution, and noise. Pollution is the change in the quantity of matter that can be harmful and unpleasant for living things. Every living things which is on the earth, they are affected by these types of pollution. Temperature rises. Temperature also rises of the of the environment, and disturbed life is called thermal pollution. Thermal pollution upset the balance of life and endangered the survival of many species. Thermal mean, whenever the word thermal comes, it means heat. A temperature due to the thermal pollution, the temperature of the earth is increasing. So this is in danger for the survival of many species. Air pollutants are unwanted and harmful natural processes such as volcanic eruption, forest fires, and dust storms add pollutants to the air. Dust storms, forest fire, these all create the air pollutants. On the other hand, the burning of fuels and solid waste in homes and automobiles factories release harmful amount of air pollutants. So these are also the source of creating air pollutants, like factories and automobiles also create the air pollution. All power plants produce waste heat, but fission plants produce the most. The heat released into the lake or river or an ocean upset the balance of life in this. Unlike other power plants, nuclear power plants don't produce carbon dioxide, but they do produce dangerous radioactive waste. So all the power plants produce the toxic material, and the and harmful materials which are bad for our health. That's why all power plants generate the heat or toxic material which directly affect the different species. In many countries, government have passed laws to control air pollution. Some of these laws, now these are the cause of the air pollution, how the air pollution is caused, how the pollution is caused. But now, how the government is taking action in some countries. So how the government is controlling these types of pollution. In many countries, government have passed laws to control air pollution. Some of these laws limit and automobiles are allowed to give off. To meet these conditions for automobiles, new cars have catalytic converters. These devices convert some polluting gases. The use of lead-free petrol has greatly reduced the amount of lead in the air. Engineers are working to improve new kinds of cars engines that use electricity or energy sources other than diesel and petrol. So in some countries, government is taking actions to how to control the air pollution. They in some countries they have the catalytic converter. Whenever the petrol is burnt in the cars, so it converts the harmful gases before going into the air into the less harmful gases. They produce the less harmful gases which are going directly into the air. So they are also introducing the lead-free petrol, which is also good for our environment. Engineers are working on the new kinds of car engines that use electricity. They are finding the other ways to work to they are finding the other ways to drive the cars on instead of uh, driving on diesel and petrol. They are driving them electricity and other sources. Many individual communities have laws which protect their areas from pollution. Individual can help to control air pollution simply by reducing the use of cars and others machines that burn fuel. Sharing rights, and how can we control the air pollution? By sharing the rights and using public transport are the ways to reduce the number of automobiles in the use. If there are less number of automobiles on the road, there will be the less pollution. So instead of using individual cars or bikes, we should avoid this and use the sharing right, like the public transport. We should use to reduce the air pollution. Next is flow diagram of energy converter. This is on page number 135 of your 9th class textbooks. In an energy converter, a part of the energy is taken, used up by the system, is converted into useful work. The remaining part of the energy is dissipated as heat energy. Sound and energy noise into the environment. Energy flow diagrams gives below show the energy taken up by an energy converter to transform it into other form of the energy. So this is the energy converter diagram. Electric lamp. So electric energy. So in electric lamp, we have electrical energy, which is an input. It will generate two types of energy. One is called the light energy. We get the light from the electric bulb, and if we touch it, you will feel warm. This is called heat energy. So electric, this is the energy diagram of electric lamp. Electrical energy is converted into heat energy and the light energy. Lamp generate the electric light energy and heat energy. Similarly, vehicle running with constant speed on a level road. So how they are converted. So block diagram will show what type of energy they have. Chemical energy, which is an input. Chemical energy, the petrol, fossil fuels, whenever the petrol is burned, so it has the chemical energy in it. So which is the input. It will convert into the kinetic energy, and it will generate heat energy and sound energy, because whenever the transport is running, it has some sound. uh, like bike has some sound, car has some sound, so it produces the chemical energy stored in our fossil fuel like petrol. It convert into the motion of the car, and it generate the heat energy and sound energy, and then we move from one place to another. It also done the work done. So chemical energy stored in the petrol is converted into heat energy, sound energy, kinetic energy, because car is moving. This is called kinetic energy, and this kinetic energy do the work done. We move from one place to another. So this work done is also produced. The last one is power stations. In power stations, potential energy of stored water. Potential energy is stored in the water. In power stations, what happened, the water is it's thrown at some height, so it has a potential energy stored in it. So this potential energy, uh, when the water is moving, is thrown from a height, has a potential energy, then it's converted into the kinetic energy. So the work done, this kinetic energy is used to run the turbines. Running the turbines, this is called the work done. And it also, kinetic energy also change into heat energy and sound energy, because the sound is also produced. This is called sound energy, and it also produces the heat energy. And the last one is this work done running the turbines, which generate the electric energy. I repeat, we studied the block diagram of the flow diagram of the energy converter. The first one is electric lamp. So whenever the lamp bulb is lit on, it produces the light energy and it provides the heat energy as well. Similarly, vehicles running with constant speed on a level road. So chemical energy in the petrol, it converted into the heat energy and sound energy. This chemical energy stored in the petrol will generate the kinetic energy, because the car is moving, and when we move from one place to another place, this kinetic energy has done the work. So the next one is power stations. On power station, potential energies of the stored water. So whenever the water is in power plants like the Billa Dam or Mangla Dam, water is thrown at some height. So water has the potential energy stored into it. When it is moving, this potential energy is converting into the kinetic energy. This potential energy is also generating the sound and heat energy as well. This kinetic energy, so when the moving water possesses the kinetic energy, this kinetic energy can turns on our turbines, and when the turbines turn, they generate the electrical energy which we use in our houses, industries, or factories. So this is the end of the topic 6.7. Student, I hope you understand this. If you have any question regarding this today's lectures, please feel free to ask. Thank you. Student, please ask questions. Unmute your mic and ask questions. This is your homework. Please memorize topic by heart and write once on the rough registers. Thank you.